This is FLOSS Weekly. I'm Doc Searls. This week, Jonathan Bennett and I talk with Dan Middleton about confidential computing. Confidential computing is a whole new category. I think it's going to be called CoCo, C-O-C-O, because 5 syllables of confidential computing is too much. But lots of other 2 and 3 and 4 letter acronyms involved. It's part of the Linux Foundation, isn't everything these days. But it's really interesting, really important, and it is coming up next.
Podcasts you love.
From people you trust.
This is TWiT.
This is FLOSS Weekly, episode 731, recorded Wednesday, May 10th, 2023. Confidential computing.
Listeners of this program get an ad-free version if they're members of Club TWiT. $7 a month gives you ad-free versions of all of our shows, plus membership in the Club TWiT Discord, a great clubhouse for TWiT listeners. And finally, the TWiT Plus feed with shows like Stacy's Book Club, The Untitled Linux Show, The Giz Fizz, and more. Go to twit.tv/clubtwit. And thanks for your support.
Hello again, everybody, everywhere. I am Doc Searls, and this is FLOSS Weekly. This week, I'm joined by Jonathan Bennett himself in his lair in Oklahoma.
The lair, yes.
Wearing his head clamps.
So I am in need of a haircut. I will give you a little secret. Yeah.
And when you take, I was trying to think what you look like when you take that. Jonathan has an enviable, for those who envy hair, I'm one of them, amount of hair, and he looks like the young Trotsky or somebody, or some literary figure whose hair goes back and then falls sideways. And yeah,
if I'm not careful, I end up looking like the aliens guy. I'm not saying it was aliens, but it was aliens. That guy. Yeah, that's not a good look. It's not what I'm going for.
You balance it a bit with the goatee.
The goatee helps, and then the headphones help a lot. It's like a makeshift hairband. Keeps me under control.
Holds them in there. So our guest this morning is going to talk about confidential computing. Are you up on this topic?
A little bit. So interestingly, I've been working through, I got an advanced copy of Cory Doctorow's book.
I have one too. I should hold mine up, but go ahead.
Red Team Blues. And confidential computing is sort of it's not really the basis of the book. It's sort of it's almost like the MacGuffin. It's the background. It's what makes the plot work. Is that someone did something very clever with confidential computing. And so I've been thinking about it. And of course, I'm familiar with the idea of a secure enclave and a TPM, a trusted platform module, and all of those things. And those are all sort of related. They're connected. They're not exactly what we're talking about, but they're very much tangential to it. So, I'm in the ballpark, and I am looking forward to asking some pointed questions about how some of these things work with open source, because historically they haven't. And I'm pretty excited about the idea that people are thinking about how to make that work.
Yeah, and Catherine Druckman, who is another co-host here and works for Intel, has already done a session on confidential computing and sent us a briefing from that. That was helpful too. So I want to get into it now. So Dan Middleton is the guest. He's the principal engineer with over 20 years at Intel. He's developed and released products in SaaS, computational imaging, blockchain, and confidential computing. An open source leader, he has represented Intel in projects including the Confidential Computing Consortium, which is on a topic today, Open Source Security Foundation, CNCF CoCo, which we can go into as well, and Hyperledger. He currently leads the Confidential Computing Pathfinding and Intel Security Software and Services Division, which in German would all be one word. But anyway, so welcome to the show, Dan.
Thanks so much. I'm flattered to be here. Really appreciate being invited.
So where are you in the world?
I'm in Minneapolis. So
okay.
It's the undisclosed headquarters of Intel.
It's so undisclosed. Does Intel know about it?
No, they do not.
That's great. So tell us about what's going on. I mean, it would give us the sort of the overall thing on what confidential computing is about, and then we could drill down into various parts of it.
Yeah. So, like you observed, we're doing things in open source. So we can talk about what we're doing in the Confidential Computing Consortium. But you probably want to know, like right off the bat, what is confidential computing? And we have a very carefully chosen definition for what it is, which is the protection of data in use by performing computation in a hardware-based, attested, trusted execution environment. But that probably did not tell anybody anything just now. So what I like to think of is data has three phases, kind of like solid, liquid, gas. And the industry as a whole, we're pretty good at protecting data at rest. So we've got disk encryption, file encryption, pretty well understood. And then we've got data in motion, data in flight. So you're transmitting it somewhere, and that's also really well understood. Pretty much everybody's going to be listening to this or have downloaded it through some form of TLS, some sort of trusted communication protocol, HTTPS, TLS, something like that. So we know how to communicate pretty well, securely, but we've gone to all this trouble to protect secrets until we actually go and use them, and then we load them in plain text on our computers. And now if you've got malware or an inside actor that has access to that host, well, when you're actually using it and it's most vulnerable, there's nothing protecting it. So that's what confidential computing is seeking to do. We protect it while it's in use. And we do that, and there's different vendor implementations, but the sort of the easy way to think about it is that memory is now encrypted. So if you have something running on that host, and it wants to go sniff something out of memory, it's just going to get garbage. The only time that your code, or the only time that your data is actually in clear text now with confidential computing, is when it's inside the CPU.
So there was your explanation really makes me think about this. There was an attack against full disk encryption back several years ago. And it was essentially, I think it was the NSA that was one of the big ones that was working on it. So someone was running, say, TrueCrypt. It's long enough ago that TrueCrypt was a thing. If they got to a computer that was turned on, they could yank the RAM out of the computer, hose it down with liquid nitrogen, and then go run over to another computer running and punch it back in. And a lot of those bits would stay in the same state because they cooled them, and they could do a RAM dump and a lot of times get that secret, the actual disk encryption key, and be able to decrypt the entire computer. And so when you're looking at trusted execution, are you essentially, that is sort of the attack that you're trying to combat?
So that is an advanced attack, but yeah, it's an attack that's mitigated by confidential computing. So for remote attackers, they're not necessarily going to be able to physically lay hands on a machine, yank a chip out, and put it back in another machine. But there's any number of exploits every day for somebody to tunnel into your machine. And so long as you keep them outside the boundary that you establish with confidential computing, they're just going to get garbage out of memory.
Okay, so does this help with buffer overflow attacks and arbitrary memory read attacks? Because you're encrypting memory, does it help with all of those? And then I've got questions about how in the world that works if it does.
So all the security principles still apply. You still want defense in depth. You still want to look at different security practices for confidentiality, integrity, and availability. You want to understand what those mean. So, we're not changing necessarily fundamentals, but we are adding in a new layer of protection. So when it comes to something like buffer overflows, if that is something that is inside your enclave, you're not protected from that. You still have to do input validation on your code if that's the code that would be exploited. But if there's something else running in your host, even in the host operating system, that's not doing input validation, and you get a buffer overflow out of that, that doesn't get to do some sort of jump into the enclave code.
Okay, so we're really talking about having two different systems in one box. Then this is what NVIDIA and the ARM world, they do with the TLK, the trusted little kernel, where you have your user-facing kernel that's running on the hardware, but then kind of squirreled away in the corner, you've got an entirely different operating system that's running that just keeps the secrets. And those two can talk to each other, but there's certain very specific rules that the operating system that we think of as an operating system has to follow to be able to talk to that tiny trusted little system. That's more what we're talking about, isn't it?
Yeah, that's a really good analogy. So ARM Trust Zone was one of the first kinds of confidential computing. Intel SGX was one of the first kinds. One of the differences between those is with SGX, you don't even have a special operating system intermediating that. You just have a portion of the segment that your program is running in. You can dial it down to a single library. And then that is just executed directly within the processor in a protected space. But on the other end of the spectrum, we now have more VM-based technologies. So Intel has trust domain extensions. ARM has something called CCA. AMD has SEV. And the RISC-V world has their own confidential computing architecture as well. And these are VM-oriented. So now the guest operating system, that's part of what we call the trusted computing base, or the TCB.
Yeah, so the VM, at that point, we're talking about a virtual machine where its RAM is encrypted, and the bare metal OS doesn't actually have the encryption keys. The hardware manages those encryption keys for it. Right. That's sort of the idea, and that is all run with things like the IME, the Intel Management Engine, on Intel chips. That's kind of the magic, the secret sauce that makes that key exchange, that kind of blind key exchange, happen.
Yeah, so there's different implementations across different vendors, but the thing that's really attractive for people, I think, with the virtual machines is with cloud computing. Mm-hmm. So if you don't want to trust that Azure, who's administering the host and operating the virtual machine monitor, that they're not going to get into your workload, or probably more realistically, that you don't trust that another tenant on that same host isn't going to find a way to read into your workload. Mm-hmm. That's where these VM isolation technologies are really popular.
Okay. Now, to get to the real meat of what I wanted to ask about with all of this, how does that work with open source? How do you make that trusted segment open? And how do you make it open in the way that we normally think of it being open, where like the end users can get in and poke around? It almost seems like these are two diametrically opposed goals, for it to be, secret and secure and nobody can touch it, and also open in the way we think of open source.
There's so many answers to that. So I love that question. So, one is just Kirchhoff's principle, which you do not want the security of a system to depend on its own secrecy. You want somebody to be able to go in and inspect how something is created, and then not destroy the security of that system just because they've been able to look inside. You want to still be able to rely upon it. Another answer to that question is that it has to be open source. And it has to be open source because of Linux. If you want a feature to be adopted in the world today, you want to make sure that that gets upstreamed in Linux. And Linux just kind of forces you to at least make some portion of what you're doing transparent. And then over and above that, we recognize the need for all those software layers that are in between the CPU instructions that we're creating and what end users want to do with it. There's a lot of layers of software. And we want all that to be transparent. So we created this open source organization called the Confidential Computing Consortium.
And I guess one of the things that I'm kind of really curious about and really getting at is, on a cell phone, This happens to be an Android phone, but it has sort of the same problem as the Apple phones do. And that is, there are certain things that, if you want to do on this phone, like get root on it, you're just not allowed to do that without a security vulnerability. And that is in the name of keeping things secure. And why is it that we're talking about this in an open source way? And I'm assuming in a way where we can actually get root on our machines. That's sort of a necessity for doing administration. And over on the mobile side, you can't. It seems like there's something of a disconnect about how much we're trusting the user. I'm not sure if that question came out right, but I'm very curious about how this works.
Yeah, I like to think of what we do with confidential computing as being very user oriented. I want to control my workload regardless of whose machine it's running on. Mm-hmm. So if I choose to outsource something to the cloud, I don't want to diminish its security properties. If I want to keep it inside my own data center, I also want to be protected from insider threats. But as the data owner or as the workload owner, I want to be able to have guarantees about what is happening with my code and my data.
Now, there's still some black box sort of magic technology. I use the term magic sarcastically, of course, but there's still some black box tech that's going on here, right? So, for example, modern x86 chips don't actually run with the x86 architecture. They emulate it because we're so far down the rabbit hole of trying to get more and more instructions per clock cycle. And so you've got kind of that x86 layer of abstraction, and everything above that we can make open. But there's still a lot below that that's closed that we really can't take a look at. And I'm just curious: is there a game plan to make some of that more open, to be able to trust this even more?
So there's definitely proprietary stuff when you get down into microcode, and some of that is less about keeping things secret and more about just the practicalities of it. But then you look at something like RISC-V. So RISC-V, fully open architecture, and they participate directly in the open source consortium that we have, the Confidential Computing Consortium.
Yeah, and it's worth pointing out, I don't know if you will or not, but it's worth pointing out that, man, Intel has actually become quite a player in the RISC-V world. And if I remember correctly, most Intel chips actually have a little tiny RISC-V coprocessor inside of them. So, I mean, kudos to you guys for helping that world come along and do some sponsorship there. And I'm excited to see where that entire thing goes.
Yeah, you and me both. I've got friends now who are working on RISC-V that I used to work with at Intel, and we're always excited to see them come present. So we do tech talk usually. We meet every other week in the consortium for a technical body, and we tend to allocate a half-hour tech talk. And one of our recurring topics is our colleagues over in RISC-V come in to give us an update on how they've progressed with their plans for confidential computing.
So I have a question around the name or the term confidential computing. And in your briefing, you abbreviated CoCo, C-O-C-O. Is it colloquially called that internally because it's only 2 syllables and easier to write?
Oh my gosh. How much time will I get back from my life if I no longer have to say Confidential Computing Consortium 20 times an hour? So people abbreviate things different ways. So we say the CCC instead of for the open source organization name. And then there is a project over in CNCF that I'm also a maintainer on that we call CoCo. And that's short actually for Confidential Containers.
And CNCF is Cloud Native Computing Foundation, right? Which is
yes, thank you.
One of the 400 or 500 foundations that are within the Linux Foundation. It seems like to me, but it's a big one. I'm actually pretty familiar with the CNCF. I've hung out with that. It's
and then if you actually dig into the Linux kernel, where some of the code for across architectures comes in. They've abbreviated that CoCo. So CoCo can be abbreviations of different things. To avoid ambiguity, I usually still suffer through saying confidential computing.
So when did that expression show up, confidential computing? Because this is the first time we've done it on this show, as far as I know, and we've been around for like 15, 16 years. So,
yeah, I think it's still a relatively new term. When we brought SGX out, we talked about secure enclaves a lot. Apple had a different definition of enclaves. So it might have been Microsoft that coined the term, but the consortium that we came together with all the companies and independent people that were working on this technology, that came around just at the very end of 2019.
So tell us about attestation, because I have a follow-up question to that does touch on some things that we've had guests on before about. What do you mean exactly by attestation? And I mean, I imagine that you need to know what's going on, obviously, but it's about validating that, I suppose.
Yeah, attestation is a central concept to confidential computing. It is one of the coolest parts of it. I'd say for like the developers in the audience, if you're listening to this podcast, it's probably because you like creating things, and attestation is this new building block that you get with confidential computing. So if you get excited for having a new kind of Lego that you've never gotten to work with before, attestation is your new Lego. And what it is the ability to remotely identify your code. So there's much more technical, precise definitions of it. But when your browser, like you want to go to your bank website, you check that little lockbox in your browser because your browser has remotely identified your bank, identified it through a certificate that sits on that computer that you're talking to. Attestation goes another degree. It's going to go identify not just some certificate that's sitting on a host somewhere. It's going to go identify your code. When confidential computing launches your application or your virtual machine, it's going to take a cryptographic hash or a fingerprint of that code as it is put into memory. And then confidential computing signs that, the components within that host that you trust, it's going to sign that measurement, that identity of your code, and send it to you. Well, you'll ask for it, and you'll get that signed attestation of, oh, this is the code that's running. It's not the code that was shipped to the box. It was the code that is actually running in memory now.
Okay, does this add a layer of complexity that some developers might not want to deal with? I'm purely guessing that because I'm not a developer myself. But
yeah, so there's two sides to the coin.
A pain, right? But
yeah.
I mean, it's a new kind of security. So
yeah, so there's two sides of the coin. One is this gives me a new building block to play with because I can actually add fields into my request to that system, and you can come up with new interesting protocols. My first foray into this work was with a blockchain protocol called POET. And so we all know that, well, people who have been exposed to blockchain know that proof of work was this really expensive, energy wasting thing. But if you used trusted execution, you could get what was essentially the heart of proof of work is a fair random number. You could just do that in an enclave without spinning a bunch of energy. But the way that you did that was to build an attestation-based protocol. So there's fun things that you can do with this tech, but it's true that security and any sort of additional thing that you have to do can be difficult. So on that side of the spectrum, we've worked with existing protocols like transport layer security. And there is a version of that called remote attestation, TLS, and that's already written for you. And if you go to the Confidential Computing's website, in our blog area, you'll even see a fairly recent post about that. And it's sort of one of the nice stories for me of open source is that we had different companies independently implement this protocol that came out of a research paper. And those protocols then, they couldn't, they were never standardized, so they couldn't interoperate. So by collaborating together in open source, we said, all right, you're using this magic number, I'm using that magic number. It's not hard for any of us to just agree on one magic number for the protocol. And now 3 or 4 different implementations of remote attestation TLS, RATLS, they now interoperate. And you don't really have to do anything special. You just get to use the protocol like you normally would.
So that's really interesting. We mentioned at the top of the show, Dr. Oz book, which I've been enjoying. Sort of a two-way attestation is his MacGuffin, and that is the way that a fictional cryptocurrency is built. Everybody's got some device that can do essentially trusted computing. And if you can do this two-way attestation, then you don't have to have proof of work or proof of stake. You can just do attestation as your proof of your cryptocurrency. It's a really interesting idea that, I don't know, may have some legs. We'll see if somebody actually tries to build it in the real world. And we've got a bunch more questions, a bunch more stuff to cover. Real quick, though, I want to talk about Club TWiT and of course, some other things that happen on Club TWiT. So Club TWiT is one of the best ways that you, our listeners, can support the network. It is just about as much as a cup of coffee a month, $7 a month, and it gets you access to ad-free shows, gets you access to the members-only Discord. But the thing that I think is the neatest is it gets you access to the secret shows. We've got some shows that we just don't tell everybody about. We've got Hands on Mac, Hands on Windows, and my show, the Untitled Linux Show. We record on Saturdays, and it is a lot of fun. And you can get into the club with Club TWiT and access those shows. It is a blast, it is a lot of fun, and you need to be there. We hope to see you at Club TWiT. All right. And now I want to ask a couple more questions about this. So we talked about attestation. I want to talk about Grameen, and not the element, not the compound Grameen, but the project Grameen. And this is, it's unikernels, right? Is that what this is about?
Yeah, so there's a lot of interrelated terms. Some people call it a library OS or a unikernel. But you even brought up earlier, often there's the need for a separate operating system in this trusted world, right, to be able to facilitate program execution. And that's what Grameen brings. So if you wanted to develop your program with the most precise level of security control, you would use one of our SDK projects like the Open Enclave SDK. But if you just want to take code that you already have and throw it into an enclave and still have more control than throwing it into a trusted virtual machine, you use something like Grameen. And Grameen has sort of a tiny operating system within it. They've intercepted the system calls that would normally call out of the trusted space into your real operating system, and they implement those in a secure way. They've done like a bottom-up implementation of the most important system calls.
So there was a set of patches posted back a couple of months ago to the Linux kernel that I thought was really neat. And of course, the Linux kernel devs shut it down as being a terrible idea. But it was the same idea that, well, what if we took some user space code, actually put it in kernel space, and then you could run this thing, this kind of Frankenstein Linux kernel that also, has Apache built into it, or has your database software built into it. And I immediately thought of, oh my goodness, that would be amazing for running VMs, because it would theoretically run so much more efficiently. And it sounds like this is what you guys are doing. Do you know, is that related to that? And I can't remember who sent the patch in, but is that related to that kernel patch? Is this something that's been pitched to the kernel devs, or is this kind of its own project that lives off to the side?
It's more, it's its own project off to the side. So there's a few different library OSs out there. In fact, even within the CCC, besides Grameen, we have another project called Oaklum. And that's a different implementation of a library OS. And that's more of a, they've got a Rust-based implementation. So if you like Rust, that's a good project to go check out. But there's a few of them out there.
Yeah, it always seems to me that that's a neat idea, though. If we're using virtual machines for separation of privilege and, to try to keep that firewall up between our different applications. But you want some of those things to be able to run at full speed, particularly if you're like only doing one thing on a virtual machine. There's a lot of overhead there, and trying to come up with essentially that unikernel idea in a way that's actually trusted. It seems to me to be a home run if we could make it work.
Absolutely. I think we'll see a lot of innovation in the guest kernel space. The more people want to use trusted execution with guests up in cloud hosts, the more people want to skinny down what is inside that guest. At Intel, we've been contributing to guest kernel hardening. So if we know that a guest is being built for running inside confidential computing, it doesn't need to have a whole bunch of extraneous attack surface. So we're trying to do what we can to help harden what's there and remove what needn't to be there.
Yeah, so we actually have a question from the chat room that I thought was a pretty good one, and it goes back a topic. It goes back to attestation. But is that runtime code signatures, which we've had in Windows for forever? It's essentially code signing by the developer, like a runtime code signature is, right?
Yeah, and I love questions on attestation because it is such a big topic for us. Mm-hmm. But it is what was loaded into memory, so it is explicitly at runtime.
Okay. And so, boy, I'm going to ask a follow-up question on attestation then. Because that means every time a library updates. So when you look at code on the web, mm-hmm. libraries update all the time, sometimes automatically, because every time you load a page, you're loading these JavaScript libraries from all across the web. And a lot of times they get updated automatically. Boy, code signing and key management for that sounds like a nightmare. How do you deal with that?
Yeah, so dependency trees are going to be a problem for everybody. If you put garbage into an enclave, you still have garbage in an enclave.
Yeah.
But there's another facet of runtime, and that was one of these building block ideas that I didn't go all the way through. And so you've loaded your code into memory, you've gotten the hash of that, so you've got the cryptographic identity of it. But then now in runtime, you can also interact with it. So if I want to send a trusted input into my program, and I will get a trusted output from it, now the output of my application is also attested. So it's not just at launch time, I want to know if this is a clean environment before I go interact with it. It's I can produce something that has a cryptographic aspect to it that I can then use for some other purpose that other people can trust because it comes attached to an attestation.
All right. So I'm going to ask you about something that I know you don't want to hear about because you work at Intel, and I just know that this is considered a curse word at Intel. What about Spectre and the other
Meltdown?
Yes, Meltdown. I'm trying to come up with the more broad term. Speculative execution vulnerabilities. Does that? What's the overlap between those and trusted execution? Is there a piece of CoCo that kind of deals with that?
So yes and no. We have a white paper in the CCC that it's called a technical analysis of confidential computing, and we've got a section in there about side channel attacks. So side channel attacks generally are difficult. The responsibility to protect against those goes both to the developer, the confidential computing provider. It touches a lot of different surfaces. So if I overextend my analogy maybe with the states of data as solid, liquid, gas, all right, well, there's a plasma phase too. And that's these side channels that come off. If you have a non-constant time cryptographic operation and you have a way to monitor power fluctuations or any of the other common side channels, you can still discover things that are inside an enclave. So the level of effort that you put into what goes in the enclave has to be commensurate with the level of trust or sensitivity of what you are going to be operating that for.
So I have some questions about how the CCC and CoCo promulgate in the world. I was trying to I was looking at your about page here, and now I've lost it where I was looking. The exact thing. But there, you have Intel, Meta, Microsoft, AMD, ARM. These are not herding animals. They are not built to get along. They're built to compete for the most part. And how do you do governance? How does governance emerge out of this? Because this is one area where I actually am involved with the Ostrom workshop at Indiana University, which is where I hang out at least half the time. That's all about how governance emerges from groups getting together, working on common goals. But it seems to me you don't have that worked out yet. So how does that work out? I mean, how do you find the common ground where you're working together on something?
Yeah, and this is one of the things that I absolutely love about open source. So Doc, you've had an entire career in open source. For me, it was the second half of my career. So the first half of my career was I got to work with the best experts, some of the best experts in the world within Intel, but on things that I might never be able to talk about. Out here in open source, not only do I get to talk about them, but I'm interacting with people, like you said, that are direct competitors. So by having the legal structure of a consortium, we get to operate in the open together, and it encourages us to work on things that we shouldn't keep secret. And we've got, as you observed, direct contributions from all of these competing and cooperating companies. And it's all through the magic of open source.
So we have a question over here. Are we approaching an API that works on multiple platforms? Is that
That's probably one of the evolutions. So when I think about like what we do in the Confidential Computing Consortium, it's Soylent Green, right?
It's people.
Exactly. So I want people to be able to come to work with us in open source, because open source isn't necessarily about the code or the APIs. It's about the people. And we really don't think that much about, I'm working with Thomas, and Thomas is at ARM. So I got to be careful about what I say to Thomas. Thomas is a great guy. I know him now from interacting with him. And we just have nice chats in, say, for example, the attestation SIG. So besides the projects that we've constructed under the umbrella of the consortium, we also have a couple of special interest groups. So if you want to learn more about attestation, you can show up to our SIG, and we record our meetings. I think we've probably got a college semester of material there. It might even be too much to just land there and try to find something of interest. But there's good material there, and there's good people to interact with. And we want everybody to be able to join us. So if you're listening to this right now and you're like, well, I've never really been involved with open source before, we want you to come over to the Confidential Computing Consortium, because there's different ways for you to interact there.
And there's room for individuals there, I assume. I mean, I don't. Linux Foundation itself is an industry association, but individuals can join this thing and be part of it.
Absolutely. So we've been talking about these big companies, but you can have just as much of a contribution by coming in as an unaffiliated person. It's not as though we check a brand when you try to enter the door. Literally everybody is welcome, and in a lot of different capacities. So we always think about code, of course, with open source, and more people recognize the importance of documentation. But like, if I could ask for help with one thing right now, it would be with a picture. We tried to put a picture on the front of the consortium's website that depicted what confidential computing is, and it confused people. So we immediately took it back down within days. And so, if you are a good developer, please come. If you're a bad developer, come. We'll help you get better. But if you are a good communicator, technical documentation is the most underserved part of any open source project. And I think even within that, if you look for, a picture is what? It's 2 kilobytes. It's 1,000 words. There's a little math joke there. But if you could help us express what confidential computing is with a picture, that would be a huge contribution. And it's one you don't even need to know how to program to make.
That's interesting. To want a picture for something, I work. I mean, my own personal focus is on economics and on customers. There is not a symbol for a customer. The men and ladies room symbol are the closest we have for symbols for a customer. That and a shopping cart. That's pretty much it. Okay, so Dan, another 3-letter initialism I see here is TEE for Trusted Execution Environment. With the emphasis on the execution, I suppose. Is that a common expression yet, or are you looking for that? I mean, in sort of evangelizing what you're doing, is that yet another thing that we want people to be talking about so it rolls off their tongue as tea and it doesn't mean golf in a couple of years?
Yeah. You'd think we get paid by the amount of acronyms we can generate, but Trusted Execution Environment is that special part of the architecture where your code is going to run. Sometimes we also use it informally to mean everything that is running in the TCB for that other acronym within the Trusted Computing base. But we specifically specified that we wanted a hardware-based trusted execution environment. Mm-hmm. So you can find things that are sort of software-based. A loose extension of that would be virtual TPMs. So you see virtual TPMs more and more in cloud environments. So you've got like a virtual machine, and because it's not a physical machine, you don't have a physical TPM. So maybe you have a virtual TPM. And a TPM is this tamper-resistant chip that you would put on the board, and it's in probably most computers now. But we wanted to make sure that we were specifying something that was very difficult for an attacker to get at. So that's why we have hardware-based trusted execution environments.
So a TPM is a trusted platform module, yet another TLA. Yes. And then there's the Trusted Computing Group, TCG. And how does that relate to the CCC, which
Yeah, so the TCG is a standards body, and they're most closely associated with those trusted platform modules. But they also produce standards that are interrelated. IETF, if you want to throw yet another acronym, that's another standards body.
I think most of the listeners knows what that is, the Internet Engineering Task Force. But so loose consensus and running code, right?
Mm-hmm. Yeah, so we have something there called RATS, which isn't so much an acronym as a compression of words for remote attestation. But some of the concepts between remote attestation you can find there. So what we try to do as an open source group is interact with these standards groups, interact with other industry groups, interact with things like the homomorphic encryption organization, other sort of related technologies, because all these things are better together.
I'm wondering if it's possible to belong to, is there a limit to the number of different Linux foundations that one can belong to? I actually myself joined the Open Wallet Foundation, and so we've had them on the show too.
So here's your little hack for the day, is that you don't have to be a member of any of these Linux Foundation organizations to be a contributor. You don't need to go sign a membership agreement. You can just show up. So if you want to learn, you can come sit in on one of our technical council meetings. You can listen to recordings. You can read what we've got up on our webpage, and you can just go directly to a project and try to interact with those project communities.
Yeah. So I'm going to pause here for a second because I think we lost Jonathan.
Yep,
I'm not hearing. We did. I'm not hearing Jonathan.
Okay,
so
hold on.
Yeah.
pause the stopwatch.
And I don't know why. I'm dealing with my mustache interfering with my nose hairs at the moment. These things happen. Maybe that's what happened to Jonathan. I wonder if you're going to actually have lost him, which is...
I see him in the meeting, but can you let him know in the IRC I'm going to kick him out of it?
Okay. Says you can finish without me. Power is gone. Wow. Okay. All right. So I'll come back and explain his absence because things happen.
All right.
All right.
Mike, here we go.
Okay. So just to bookmark this, we have actually lost Jonathan because he lost power in Oklahoma. He's had a problem with this earlier, and I can't blame that on his kids, I guess, but it's probably just that kind of stuff. So, I'm wondering, because we have the Linux Foundation, it's kind of a bigger and bigger topic in the sense that it comes up more and more often. So I want to understand more about how the overall ecosystem works there. And also, well, I have another question to follow that. So I'm wondering, is there much play between them? Is there like the equivalent of a Slack channel behind all of it where you can cross-fertilize, or just all of them are independent enough that that doesn't matter?
A little of both. So we have an objective in the Confidential Computing Consortium this year that those of us that are on essentially the steering committee for it, we want to be very cognizant about what we're doing, very directed with what we're doing. And one of those things is to do more cross-pollination. I happen to be also a maintainer on a CNCF project, the CoCo project that you mentioned. There's no direct connection between confidential computing and between the consortium and the CNCF, but we've got people who are doing projects in both spaces. And that goes for other parts of the Linux Foundation. So there's also an interesting, also relatively young project called the Open Source Security Foundation, OpenSSF. And we've got contributors that go between the two of those. So right now, I would say that stitching together the fabric across these Linux Foundation projects is, again, people, more so than tools, more so than any particular medium. But we've got people that go between them, and wherever we can forge those connections. Usually, something interesting arises from it.
Is the OpenSSF the one that Brian Bellendorf went to from Hyperledger? Is that a different one? Okay.
Nope, that's the one.
And we've had Brian on the show too. He's he's a star in his own right. Anyway, I'm wondering about industries and verticals. When I went to the CNCF gathering in San Jose a few years ago, I'm thinking cloud native. Okay, cool. It's interesting, cloud native. And I found out that most of the action was actually about cellular telephony. It was all about getting local storage as 5G rolled out. Now that was several years ago. That may have changed. And I'm wondering if with confidential computing, if this appeals to a particular vertical of some kind, or a collection of verticals that, like, what is a typical environment? If you want a trusted execution environment, what is a typical place that's going to go?
That is a really good question. So it goes across, it probably has most affinity to verticals that are already sensitive about security. So the financial sector, they are under different compliance obligations to protect their customers' data. So healthcare would be another one. So there's, again, some compliance requirements underneath their interest. Blockchain, there's no compliance requirements, but again, there's the opportunity to do something new with security that helps address unique requirements. And then another one would be AI. And this is, you can't have a conversation now without talking about AI. If you go into the Grameen project, there's a contrib repository where people can put things that they've customized so that they know that it works well with Grameen. In there, you will see Redis and PyTorch. And if you're involved in AI, those things probably, those things mean something to you. Sorry, I said Redis, but PyTorch and TensorFlow. We also have Redis in there and MySQL and a few other things. But one of the use cases that comes up for AI is, how can I, in a safe way, send my data in to be processed with a bunch of other people's data? So if Doc is operating a service and he's going to let people send data in and it's going to get mixed together and enhance the learning model, is Doc going to sit there and look at everybody's medical information, everybody's financial information? You can launch a confidential computing environment so that even though Doc's running the service, he doesn't get to look inside. So it gives people a trustworthy way that they can send private information into either developed learning models or be processed within already trained models.
So I have a question about provenance. So you talked about attestation earlier. Mm-hmm. Provenance is a term that's come up more often in some of our recent shows, and just in something you hear in the water, as it were. Does it show up with you guys as well, as a cousin of attestation?
It does, and I think this is another one of these areas where it's yet to be developed, and it's an exciting place to be able to come up with something that people haven't defined yet. So we hear a lot about, with provenance, software bill of materials. Where did these bits come from? Were they properly built? Was there something injected along the way, like with SolarWinds, with that attack? And so my thinking is that with attestation, you can kind of bookend that entire supply chain. You can identify this was the code that was built 10 days ago on, a server in California, and now that code, based on its cryptographic identity, is the code that's now being run in Helsinki on some server that you don't have control of.
So you brought up AI, and I lately, I think I don't want to get this wrong, but I think somebody at OpenAI, may have been somewhere else, said that while they're very pro open source and as much as they can be pro about, they really see open source development as a threat with AI of some kind. And I'm wondering what your thoughts are about that, because I think this is going to be a gigantic topic in development circles over the next coming year or a few.
Yeah. So Intel is really interested in democratizing AI. And maybe one of the ways that happens is making training models more accessible to more people. And something like confidential computing lets people train their own models and still protect them. So it might still be kind of closed source in the sense of, I don't want this model that I have invested in. I don't want to make that widely available. But it does something with the economics, where now it's not just one or two or three giant companies that control the most important models. It's more accessible for more companies to create more models without the same sort of economic risk and economic investment.
So Jonathan was talking earlier about his Android and situation with that. I have here an iPhone, and I wouldn't call it a trusted computing environment. I'd call it a trust me computing environment. Okay. Apple's saying, trust us. Trust me. I'm Apple. I'm out to help you. I don't have an interest in advertising to you, except on our own stuff, as it were. But on the other hand, I tend to think that, and I wrote a piece in Linux Journal a long time ago about this, that if your privacy in the hands of somebody else, you don't have any. And I'm wondering if there's hope in the future that a trusted computing environment is part of what you get with every phone. I mean, these are extensions of ourselves now. And you can't go anywhere without your rectangle in your pocket. That is an extension of yourself, but it's not yours. It belongs to Apple or Google, and that's pretty much the world we're in right now. And the open source alternatives, like for purism, are pretty rare. You have to be a hardcore geek to want one, but though it's worth having. We're at the mercy, as it were, and I'm wondering if there's hope in what's going on with your work with the CCC and we go down the long list of 2 and 3 letter acronyms. Is there hope for that?
Yeah. And I hadn't thought about it in that way before, but you don't even need a trusted execution environment on your phone in order for this to be beneficial, because in reality, most of the data that's on your phone is only temporarily resident on your phone. Most of the time, it's going to be up in a cloud server somewhere. So that's where a lot of the confidential computing technologies are being deployed. So to the extent that your data, while temporarily resident on your phone, is going to be resident in the cloud somewhere, the benefits of confidential computing can be realized through that aspect of it.
Jonathan has reappeared. So with new lighting.
I am in the middle of a power outage, interestingly enough, and I have some very nice battery backup. So I now have a cable running across the floor to get over to my camera and my microphone so that I can come back to you with some great lighting. Hey, I know we're really close to the end. There's a question I love to get in, and I think it would be a great one here. With the confidential computing, what is the most unusual thing that you've seen someone do with this? What is the use case that someone has come up with that has the most surprised you?
Oh my gosh, that's a tough question. I'm going to pause for just a sec on that.
Bring the hard questions.
So I've kind of mentioned these because they were top of mind. Poet for me was one of the most interesting things because it didn't focus on confidentiality. So we call it confidential computing, but arguably we should have called it integrity computing. So in security, we've got the CIA triad: confidentiality, integrity, and availability. Confidential computing gives you the C and the I, and you have to compose the availability. So what this proof of elapsed time protocol did was it helped compose availability, sort of by rote of being a consensus within a blockchain. But then what it really focused on was the integrity. I could trust the output of a program being run on every other blockchain participant's computer because they could not tamper with the program. They could not tamper with the output. And it had almost nothing to do with encryption or confidentiality. So, if there was one really innovative thing I would say for confidential computing is don't think about the confidentiality, think about the integrity.
That's a good distinction. We are down at the end of this thing now, and we always close with two questions, which are: what are your favorite text editor and scripting language?
So I have grudgingly come to love Vim over the years because I can just show up on somebody else's machine and I don't need to recustomize the environment for myself.
Yeah.
And Python is such a good thing, even for experienced programmers, but for new programmers, you can actually see what's happening with your code live. So I love Python. I love Vim.
I don't even know who did the bell. I know that Jonathan was trying to defeat bells going off when his power went off. It's like, and I'm looking at the ceiling thinking, oh no, do we have a smoke detector here that's about to go crazy? Because in this house, they're all connected to each other. So turning off one does not turn off all the others. Oh. Anyway, it's one of those. And of course, it's smart. That's why it does that.
Smart, yeah. Anyway,
it has been awesome having you on the show, Dan. We have to have you back to talk about how this progresses, because it deserves to be a hot topic.
I have loved being here, and I would love to come back any other time.
That's great. So we'll see you then.
All right. Thanks.
And Jonathan, it looks like the screen behind you no longer says Hackaday on it. So my guess is that it's showing whatever default thing is set up for that.
Yeah, who knows? I think that's the power outage. That's the power outage map behind me. There, we're in the in the red. Yes, we're in the red, meaning that we don't have power still. I didn't even think about that. That's in fact the one screen works. The big TV is not on the battery backup, so it's just interesting around here. Anyway, confidential computing. I love that they're working on it with open source. Very fascinating stuff. I'm looking forward to the different players coming together with sort of a shared API that works with this. So, ideally you could have a programmer just write their code once, use some API for trusted computing, and be able to run it on an Intel box, an AMD box, an ARM box, a RISC-V box. There's all these different places that it makes sense to have this sort of thing. On Android and on iOS even too. It would be great to get those two players in this ballgame too. But from what I understand right now, we're kind of having to piecemeal it and have different implementations for the different architectures. And so that seems to me like kind of a downer for really pushing this to the next level as far as, making it available for everybody. But at the same time, these extensions are in processors right now. You can go run an Intel server with encrypted VMs. You can go run an ARM server and do some encrypted stuff with trusted computing. And so it's out there and it's neat. And I'm glad we got a chance to let people know about it.
Yeah, I love it too for the fact that they're going about it with open source. Open source seems to me it is the way, the only way I think maybe that the world has to get along. We depend on tech. Tech is going to utterly eventually rely on open source to work things out.
Yeah, and you think about a technology like this, and there's no way anybody would trust it if it wasn't open. If we couldn't get into it and see what's going on the inside, it's just it's not trustworthy at all without that part.
And I noticed that, and I don't know, I didn't look at the smaller names in it, but Apple is not in this one, and they're gigantic. And I think that's the as I called it earlier, the trust B environment or trust them environment. And I think there's a coming conflict between two mentalities on that. Mm-hmm. And and is showing on the video side of this thing. I don't see Apple in there, so you could show more. Yeah, that's the page I was looking for earlier, general members. But but there's conspicuous by its absence, I suppose. Especially as more and more of us come to depend on that company and that platform. It needs to be open, needs to happen. So you got stuff to promo there, even though you can't show it in your background?
No, I won't have it in the background. I'm sure Ant will have me covered though. So we mentioned Club TWiT and the Untitled Linux Show, a lot of fun. But the other place you could find me is over at hackaday.com. And we've got the security column there. This Week in Security goes live every Saturday. I'm about to lose power. I better hurry. So it goes live every Saturday. And then, look forward to the coverage of Dr. Oz book coming soon as well. I got to go. Bye.
What's the title? I got to go by. His beeper's going off. Oh, my God. He's getting played off by his own system. And for those of you not seeing this, he walked off camera to go turn something off. Anyway, it's still going. Oh boy!
Now that's how you end the show, Mr. Searls.
That's how we end the show. But before we go off, I want to promo next week. It is Greg Crow-Hartman. He's back. He was here about 6 months ago. Greg is an alpha maintainer with the Linux kernel, and an extremely interesting, entertaining, and fun and useful guy to have on the show. We're really privileged to have him back. So that's Greg KH coming up next week. Until then, I'm Doc Searls. We'll see you then.
It's midweek, and you really want to know even more about the world of technology. So you should check out Tech News Weekly, the show where we talk to and about the people making and breaking the tech news.
It's the biggest news. We talk with the people writing the stories that you're probably reading. We also talk between ourselves about the stories that are getting us even more excited about tech news this week.
So if you're excited, well, then join us. Head to twit.tv/TNW to subscribe.